All right, so this is the video for section 2.3. The first one we're going to look at is number 21. And so for number 21, they're just asking us what would be the degree, the possible degree for this one. Now, the thing that we have to look at is that the right end and the left end are both up, right? So the right end and the left end are both up. They're increasing. So there are 3 turning points. And so therefore the degree is an even integer. And it has to be greater than or equal to 4. And so the x to the nth term has a positive sign. For number 23, the right end, I'm going to put the right end is up. The left end is down. There are 4 turning points. And you would have to look at the textbook for this one. And so it's an odd integer. And it has to be greater than or equal to 5. And of course, x to the nth power is also a positive sign. So that's how you look at number 21 and number 22. Looking at number 27, what they're asking us to do is to find the asymptote. So in order to find the vertical asymptote, and I'm going to write it as VA, we're going to set the denominator equal to 0. So remember, a rational function f of x is the ratio of 2 polynomials. So I have p of x over q of x, and as long as q of x is not equal to 0, right? And so that's the definition of a polynomial function. And so when we look at number 27, they're asking us what is the vertical asymptote. So what we're going to do is we're going to set this equal to 0, and we get x is equal to negative 2. So the line x is equal to negative 2 is the vertical asymptote. In other words, this function will approach that line, but it will never ever touch the line. Now, the next thing is that they're asking us to look for the horizontal asymptote. And so the way that we look at this is that if the degree of p of x is less than the degree of q of x, then the horizontal asymptote is the line y is equal to 0. And so if you look at the degree of the numerator here is equal to 0, right? So it's negative 4x to the 0 power, which is just 1, so it's 1 times negative 4. Now the denominator is a degree of 1. So again, if the degree of p of x, which is numerator, is less than the degree of q of x, it's just the line y is equal to 0. Now, there are no x-intercepts. And the reason being is that when we do the x-intercepts, we make y equal to 0, right? And so since this function can never be equal to 0, the numerator can never be equal to 0, there are no x-intercepts because we can't make negative 4a equal to 0. Now, the next one is the y-intercept. So what is the value of y when x is equal to 0? And let me just write this here real quick. And so when x is equal to 0, we get 0 plus 2, which is negative 4 over 2, which is negative 2. So then the y-intercept is negative 2. So there's no x-intercept. The y-intercept is equal to negative 2. So now looking at, we're not going to graph this one. So look at number 28. Again, the vertical asymptote then is just going to be x is equal to negative 3 because we set the denominator equal to 0 and we solve for x. The nequest thing is we look at the horizontal asymptote, and again, so remember, we have a rational function which is p of x is equal p of x over q of x, and so we look at p of x, and p of x can never be 0. So horizontal asymptote is going to be the line y is equal to 0. So that's going to be the horizontal asymptote. Again, the x-intercept, since we cannot make p of x equal to 0, there is no x-intercept. And then the y-intercept, we just make x equal to 0, and so we are going to end up with negative 1 over 3, and so that's going to be our y-intercept for number 28. All right, so number 31 is basically the same, right? The same process that we have. We're going to find a vertical asymptote, and in this case, it's going to be the line x is equal to 3, because if you set x minus 3 equal to 0, you get x is equal to 3. Now, the horizontal asymptote is going to be basically what we do is if the degree of p of x is equal to the degree of q of x, then what we're looking for is we're looking at the coefficients. So in other words, if I have a over x and then b over x plus some value c, then the horizontal asymptote, let me write this here as horizontal asymptote, it's just going to be a over b, right? That's going to be our horizontal asymptote. And so when we look at this one, we have 2x over x, because the degrees is the same, so that's just going to be 2, so then the horizontal asymptote is y is equal to 2. Now the x-intercept is going to be, when x is equal to 0, when y is equal to 0, we set y is equal to 0, we're going to get that x is equal to 0. And so, again, the y-intercept will be the same, right? Because it's just the, if x is 0 and y is 0, then y is going to be 0 when x is going to be 0. And so, if you think about it, if I set p of x equal to 0, I get x is equal to 0. If I set the function equal to 0, right, so the y equal to 0, I'm just going to lay it out here so we can see it, we get 0 is equal to 2x, which again is just the same thing that we had the first time. Number 33 is similar, so the vertical asymptote, we're going to set the denominator equal to 0, and we get x is equal to 4. The horizontal asymptote, since the degree of p of x is equal to the degree of q of x, is just going to be y is equal to 1, because it's x over x, which is just 1. Now the x-intercept is going to be, for this particular one, we're just going to set y equal to 0. So we set y equal to 0, right? And this is how you would solve it. Multiply both sides by x minus 4, so we get, and then here we get x is equal to negative 1. So that's the x-intercept. The y-intercept, we're going to set the denominator equal to 0. Basically, if we make x equal to 0, we get 0 plus 1, 0 minus 4, which is negative 1 over 4, and that's the y-intercept for this one. All right, looking at number 35, which is the same process, right? We're going to first find the vertical asymptote, which means we're going to set the denominator equal to 0. So 4x is equal to negative 20, and x is equal to negative 5. So that's the vertical asymptote. The horizontal asymptote now, again, since the degree is the same, what we're going to do is we're just simply going to say it's going to be negative 2x over 4x, which is just negative 1/2, right? So y is equal to negative 1/2. So that's the horizontal asymptote and the vertical asymptote. The x-intercept. So for this one, if we make y equal to 0, multiply both sides. Right, so 2x is equal to 3, and x is equal to 3 over 2. And that's the x-intercept. The y-intercept, of course, we're going to make x equal to 0. So then y is going to be equal to 3 minus 2 times 0, 4 times 0 plus 20. And we're going to end up with 3 over 20 for the y-intercept. All right, looking at number 39, we're going to do the same process. The first thing I'm going to do is I'm going to factor p of x, and when we factor p of x, we get x plus 3, x plus 4 over x plus 4. Now, when we reduce this, we're actually just going to end up with x plus 3, but x cannot equal 4, right? So that's the restriction. So what happens is that there is a hole. There are no asymptotes, but there is a hole when x is equal to 4. So if I were to graph this, right, this would be my negative 4. Sorry, not my negative, my 4, not my negative 3. That would be 4 right there, and that's just the hole. So there are no asymptotes whatsoever. Now the x-intercept, for this one, if I make y equal to 0, I get that x is equal to negative 3. And then again, if I make, for the y-intercept, I'm going to get x is equal to 3 if I make x is equal to 0. So that's no asymptotes because there's a hole. We cancel out the common factors and we end up with x plus 3, which is just a linear function, but x cannot equal 4. All right, looking at number 46, this is one of the first word problems that we have for this one. And it says, suppose that the average cost per unit, C bar of x in dollars, to produce x units of yogurt is given by C bar of x is equal to 600 over x plus 20. So what they're asking us is to find C bar of 10. And so we're just going to plug in these values here to get that. So C bar of 10 is going to be $20. C bar of 20 is going to be $15. C bar of 50 is going to be about $8.57. C bar of 75. So I'm just plugging in this value here. It's going to be about $6.32. And then C bar of 100, it's going to be about $5. So we plug in these values and that's how we get it. Now for part B, it's asking us which of the intervals, right, 0 to infinity or bracket 0 to infinity would be more reasonable for this particular function. And so what happens here is that 0 to infinity is more reasonable. And the reason being is because for this one, 0 is part of the solution, but it doesn't make any sense to find the average cost if we don't produce anything. There wouldn't be an average cost. Now, for part C, they're asking us to find the vertical asymptote and all that good stuff. And so the vertical asymptote is going to be x is equal to negative 20. The horizontal asymptote is going to be the line y is equal to 0, since the degree of the numerator is less than the degree of the denominator. Now, if we were to make, for the x-intercept, there's no x-intercept, but the y-intercept is going to be y is equal to 30. And so that is number 46. Number 47, I'm going to leave it extra for you guys. So let's look at number 51. So number 51, it says, suppose a cost-benefit model is given by y is equal to 6.7x over 100 minus x. So here we have y is equal to 6.7x over 100 minus x. And so what they're asking us is find the cost of removing each percent of pollutants. And they start with 50%, and they go all the way up to 99%, I believe. And so when we do that, we're going to have to plug in So when x is equal to 50, we're going to plug in the 50, since they're asking us for a percentage. So the reason I'm doing this is because what happens is, so that's about 6.7, which is 6,700. When x is equal to 70, so you get 6.7 times 70. And the reason being is because they're asking you for the percent. So they're already giving you the percent, so you don't have to do anything else. So this one's 15.6, which is 15,600. Now I won't do all of them. You guys can pretty much see. So the last one is when x is equal to 99, which is 6.7 times 99 over 100 minus 99, and you get 668.3, which is 668,300. Now the next one is, can you ever remove 100%? And you cannot remove 100%, because when x is equal to 100, that is a vertical asymptote. So you can never remove 100% of the pollutant. And number 52, I'm going to leave it for you guys as extra, and that's the end of 2.3.